each other. So action, one force can be said to be action force, and the other force can be said to be a reaction force. So these are the things, action and reaction. So this kind of thing you can see in many conditions. Suppose that you are pulling water from a well, right? We are putting a pulling force on the rope. So in the rope there is another force called a tension is created, right? Tension and the pulling force are in the opposite directions. Suppose if the pulling process is on, the pulling process is going on. Suppose that all at a sudden the rope breaks, then what will happen? The pulling man will go in the forward direction. Why that happens? When the rope breaks, the reaction force vanishes. So because of the reaction force only, the system is in balance and the man is able to pull it. When the reaction force is vanished, only one force, only pulling force only will be there. Reaction force is not there. The man tended to fall backwards. So the same thing you can see that when a gun is fired, when a gun is fired, you see, due to change in momentum, the bullets are moving outwards. That is called action force. In the other hand, in the other hand, this moving bullet will put a force on the gun. That is what is called recoil of the gun. A backward force is acting on the gun. One is called action force, other is called reaction force. This is called a recoil of the gun. When a person operates a gun, when he fired, then he has to keep the the base of the gun very close to the collar. That means this muscle, right side muscle, very firmly. Otherwise, that can, due to recoil of the gun, that can break the collarbone. Right? This is called recoil. This one is action, and other is reaction. This kind of force are always existing in the in nature. Right? That means when so many places we can understand this kind of forces are existing. Right? So but because of the action and reaction only, we are able to walk on the floor. Suppose a person is walking on the floor. A person is walking on the floor in a straightforward floor. A person is walking along like this. Suppose this is the position of the foot of the person. In the process of walking, at any instant, this is the position of the foot of the person, and he will give a jerk to the surface of the floor on which he is walking. That jerking force is what is called F. This is called action force. So against every action, there is an equal and opposite reaction. So reaction force also will act in the opposite direction. This is called reaction force. This is the person's one foot that is acting a force, making angle theta with the horizon. This is the horizontal direction, and against this force of action, a reaction force is acting in the opposite direction, just opposite in the same line, but in the opposite direction. Magnitude will be same. So why it is also making an angle theta? Because the action force makes an angle theta with the horizon. The reaction force also will make an angle theta with the horizontal, right? This reaction force can result into two components. One is along this direction, other is along this direction. Naturally, this is H and this is P. This can be taken as equal theta only because there is no change. So this is horizontal component of reaction force, and this is vertical component of the reaction force. Vertical reaction force, that is equal to R sin theta. Horizontal component is equal to R cos theta. Right? This is equal to H is equal to R cos theta, and V is equal to what? R sin theta. And R sin theta actually balances the weight of the man who is walking on the floor. So these two balances. Balances means what? V is equal to mg. That is why the man is not going into the floor. Right? He's on the surface only, settled on the surface only. Hence, we can say that the vertical component, the reaction force, is balancing the weight of the man. That is cancelled because both are acting on the same body in the opposite direction, cancels. But one thing is remaining. What is that? R cos theta has no balancing part. In the opposite direction, there is no balancing force. That is imbalanced force. This imbalanced force takes the body in the direction of the horizontal direction. That will give acceleration to the man, and the man is able to walk on the floor. Right? The same thing is the case of a horse and a cart. Also, the same thing is happening. A horse is there, and also a cart is there. Cart is on the floor and its weight is acting downwards and a reaction force is upwards. Both are acting on the cart, that cancels each other. Then the problem arises with the horse. Horse will walk on the straight floor at a particular position. Its hoof will give a force in the downward direction, make an angle theta with the horizontal. Am I correct? This is the condition. So cart and other things are there like this, and this is horse will be here. Right. That diagram I am not making. It is difficult to make. It will take time. That's why. So here is the horse, and these were connected by a string. String also, one force is acting on this direction, other force is acting on this direction. Both are internal forces that also cancels each other. This is cart. Cart weight is acting downwards empty like this, and reaction force is acting on the same cart in the opposite direction, right? Okay, both are on the same body, so therefore that also cancels mass, weight of the body, and the reaction force cancel each other, right? Because cart is not moving downwards, so cart is on the floor only. That cancels it. Then the thing about that, this is the position of the horse. Horse make a force in the downward direction in a that means make an angle theta with the horizontal, right? So a reaction force is acting in the opposite direction. This is R here, right? This can be resolved into two components. A reaction force can be resolved into two components. One is a horizontal component that is called as H, and other is called a vertical component that is called V. So all these are force and action on reaction, right? Okay. So this is action, this is reaction. How the cart move forward, that we are going to discuss, right? Next, this V is balancing the weight of the horse. That means weight of the horse means weight of the horse is balanced by the vertical component. They cancel each other because the horse is not moving downwards due to its weight. Why? Because that is balanced by the vertical component of the reaction force. Right? So the horizontal component of the reaction force that takes the whole thing forward. One more thing is that as the bodies are moving on the floor, there is another force acting that is called a frictional force. So in the horizontal direction, two forces are acting. One is called a frictional force, other is called a horizontal component of the reaction force. Therefore, net force is equal to net force. In this case, net force is equal because body moves in the horizontal direction only. Therefore, horizontal component of the force is greater than the frictional force. Therefore, net force in the horizontal direction is equal to the big horizontal component minus small frictional because the body is moving in the forward direction only. So, forward force is greater than the backward force, right? Backward force is what? That means backward force means reaction, frictional force because the body is moving on the surface of the floor. Therefore, frictional force is acting in a direction opposite to the motion of the whole system, right? So the horizontal component that H is equal R cos theta only, that I am not mentioning, only H I am mentioning here. So in this case, net force is equal to H minus F we can write. H minus F we can H minus F. This is the total what? Forward force. This forward force takes the body in the forward direction with an acceleration. What is the mass of the body? Mass of the whole system is equal to mass of the cart plus mass of the horse. Right? So acceleration provided for the cart and horse is due to this imbalance of the force. This imbalanced force is or resultant force is equal to H minus F. By Newton's second law of motion, we can write net force is equal to force into acceleration. That is H minus F is equal to mass into acceleration. Total mass, what is that? Total mass means mass of the cart plus mass of the horse, the whole into acceleration. This is mc, that is the mass of the car, and this is mh. Mh is the mass of the horse, that into a total mass into acceleration. Because due to the imbalance of force, both the car and the horse are accelerated with the value a. So net force h minus f in the forward direction, the net force is equal to mass into acceleration by second law of motion. So hence from this one, we can calculate A is equal to h minus f divided by mc plus mh also we can write. So this is cart and horse problem also solved. Am I correct? So this is this is then applications of so okay. This is also O. So H minus when. One more example